I was just saying that we started off with Bitboi, the 8-bit NES game that I've been building for Trevor. So, have to dust it off. We're dusting off the new setup. This is the second time streaming on this setup. So lock and load. I'm sure there's going to be some bugs that we're going to have fun looking for tonight, or this afternoon rather. So, we got... So where I left it, we started doing the level editor. So we had we basically were manually doing the level in the code, which of course that's always a winning combination. But and the way we were doing that was, so I was basically just hitting the code directly. So this is the draw list. So I'm not gonna go too much into NES assembly, the way the stuff works. I'm trying to use the Shiru, a derived version of the Shiru library, so that you can actually program in C. But if we have to bust out some assembly, we'll get there. 6502 is definitely a fun chip to work with. So what we were doing on load level, which gets invoked by the main game loop, was basically we're setting up that we're going to, we got the PPU off. So this is the one time that you get to do this is you can shut the PPU off on a scene transition. You really don't want to, better if you don't ever do it, but it's okay that we're at the attract screen and we're going to just flash real quick, and then we're going to head over to the and fill in the background. And that's kind of what I was doing the other night. So we managed to get, so before I was just blitting out, the whole thing was basically empty, and then I had a few lines at the bottom. And then we started playing around a little bit with adding kind of an upslope kind of mountain thing. So I think today we're going to actually start doing this kind of the right way, which is let's load this thing in from data instead of assembling it in code. The original Bitboi game that Trevor made in GameMaker was I think he had a couple levels of it, and they're static maps, and it doesn't side scroll, so we don't have to worry about doing split scrolling or anything kind of tricky. And by the way, hello everybody in chat. Nice to see all of you. Is this kind of a good time? I mean, so one thing we were talking about, for those of you who are not on the Discord, I should just drop that real quick. I'm playing around. I want to start having a regular schedule that's posted. One of the things that went wrong in the early show was I kind of scheduled what was going to be in every week, and that gets crazy because sometimes you run into trouble with getting your RISC-V disassembly to work, or whatever, and sometimes life just creeps up. But I think it's better if we just have some regular time slots. So if you jump in the Discord, then I'm eager to hear your thoughts, especially if you tune in somewhat regularly, about what kinds of, I've got a couple days. I'm thinking of mostly doing, with Tuesday nights we have the learn session, and I think Saturday afternoon seems to be all right. So I'm thinking of keeping this time, but I'm sort of floating on, should I go with Thursday night or should I go with Friday afternoon? That's kind of the big question point. So anyway, sound off on that in the Discord, and we'll figure all that out. But anyway, today we're dealing with the NES, not scheduling. What we're up to kind of here is this is sort of assembling the graphics in the C code. So we're letting CC65 assemble this whole thing and then put it together in the binary. But what would be nicer is if we had, and nicer in the sense of I think we have a little memory to waste, and you don't have much memory on the NES, but I think it's fair to burn a little bit of ROM space. Just let's start off simple and then get more complicated if we have to. So I'm using an RLE routine based on the Shiru code to do the attract graphic. So that's kind of how I encoded that. So let me just pull that up real quick. So we'll go in here and we'll just run this thing. And hopefully, Windows coming up. So this attract screen is kind of blown. This is just built right into the binary, and I'm just on the fly blitting it out to the PPU, and then that's where I'm releasing the PPU in the startup screen. That kind of logic is pretty decent for something like the level, but rather than start off with the complexity of the RLE encode, which it's not terrible, but it's not trivial either. Let's see if we can just get away with burning like ROM positions, So this is like, if I'm remembering correctly, this is something like 32 tiles across, and 27 tiles plus a couple rows here at the bottom. So about 30 tiles down. So if we do like 32 by 30, that's, well, let's do some math here. 32, 30, that's 960 bytes would be thrown away for the level data uncompressed. Now, obviously, that could be, run length encoding would get you a lot of savings because a lot of those tiles are empty. So like they'll repeat very easily. But before we do that, let's just start off by burning it and getting our level to work, and then we'll worry about run length encoding it. One of the nice things about having it uncompressed on the ROM is that we can probably use that for our physics and our hit detection as well. So we can tell whether or not there's something in the block just by taking a look. I think I think let's try to stay simple, and then if we need to get complicated, we will. So we'll start off with the naive implementation. So that kind of gets to like, all right, well, what are we going to do for a level, and how are we going to pack it up and then load it? So we need 960 bytes in to do this. So I think the easiest thing to do is probably just to draw it. So that's why I was playing around a little bit with Pico Pixel, and we could I don't know. Let's take a look at that, and then let's try that for a workflow before we kind of go crazy. All right, so this is our current sprite that I packed in. So this is the left foot, and then of course we got the right foot. Now I discovered that we're going to go with we're going to go 3 down, and we're going to go 2 across. So we're going to burn 6 sprites in order to do the main character. So that's roughly the size of a Super Mario. So that's cool. But let's use this to do kind of a level design. So I think what we want to go with today is, let's make a new window. And of course, we're probably going to have to mess around a little bit to get it to pick that up, which is going to be, let's say 32. What did I say for the coordinates? They were 32 by 30, I want to say. Yeah, 32 by 30 is what I was saying. All right, so we'll do that, 32 by 30. And let me just save this because OBS likes to take the title of the window as sort of the the capture point. I guess it doesn't want to grab the, we'll call this level 1. It doesn't want to grab the X window reference. All right, so do that, and I should be able to switch this real fast. So that would be level 1. All right, cool. So we get a blank screen. All right, and then we can take this and close it. So I'm gonna get rid of that. All right, got to get some water and then get a FreeBSD compile going on. Wow, Erotzen plots. That's a big day you got today if you're gonna recompile everything. All right, so what's nice about this is it's a lot easier than just writing out binary or hex or whatever. So let's just see if we can get like a full cycle working here. So I'm going to put corner dots. Let's do 3. And because I want to spend more time programming than level designing. And let's see if we can just pack this up as 2-bit and get it spit out as binary and then get that loaded in the ROM. So that'll give us a good idea. And then here, just because that cycle is kind of long, we'll put some stuff like, I don't know, we'll do one here and one here. Just in case I'm misaligned, we should be able to see it by how many of these we can get. And we'll do that. I'm sure there's a mirror mode available. And of course I'm off. So let's not do that. Okay, let's do that. And what's the key combo on this thing? No, not that. No, not that either. You know what? I'm going to do it the old-fashioned way. Nope, that's not how you do that. All right. Huh. That wants to be annoying. Yeah. No. All right, you know what? I can redraw it faster than we can figure this out. And we'll just get rid of these. Wow, look at that. Magic. Okay, so this should give us a pretty good layout to make sure that we're hitting the screen right. So let's just save this and export it as something that's easy to read in. So you know what? It's actually putting a header on just about everything. So let's use a PNG because those are relatively easy to work with. Okay. So if I cut back over here, then we should have an image we can see, which is level 1. Okay, cool. And I just want to make sure that it exported all the levels, all the layers here. Okay, cool, it did. So we need this PNG to be in a more mungible format. I think let's try to use convert for that. That might help. Well, FreeBSD 13 current on ARM is always very entertaining. Arrows and plots, you are a brave person. that's a pretty interesting compile combination you got going there. Are you trying to run FreeBSD on a Raspberry Pi or something? What are you doing with? Or are you going for like ARM instances or that? I feel like there's a story there. I think like one does not lightly compile FreeBSD and ARM. One does not walk into Mordor. Okay, all right. So we're gonna go look at. It is running on there, on the Raspberry Pi. Nice. Well, you've already done a lot of work. Man, just getting the bootloader to work would be a lot of work. I mean, all right, so I can cross compile it from. Yeah, sure. I mean, I'm assuming you didn't want to do it on a Pi. that would be a lot of work. You know what? So just so that Cam is happy that I'm actually sticking to my 10 lines of code an hour, I'm gonna do this real fast in Pill because it'll probably with Python it'll probably be faster than trying. I'll take one stab at doing this first. Let's do this to RGB format. Unfortunately, I don't really want RGB format. I feel like that's, of course, image formats is like in a different page. Yeah, format. Yeah, just look at the web, basically. There's a, yeah, all right, it doesn't say. So we'll, yeah, that'd be hell to do on a Pi itself. Sure. I mean, you'd basically need to start by building a Pi cluster before you even, I mean, just building something as large and complicated as FreeBSD would be like kind of crazy. Let's just see if we have like image magic, converts, black and white, binary. I mean, I know RGB works, but that gives you RG and B, which we really just want. All right. That's, yeah, it's going to take a while. All right. This will be faster. What was the line that Primogen just tweeted out yesterday? That it was a fantastic line. Someone from his channel said, I'm gonna screw it up. It was like you could do hours of trial and error is always better than a few minutes like looking it up in the manual. I have a feeling this is going to be one of those moments. I drank coffee about an hour ago, and now I am twitchy and edgy. All right, Cam. Well, let's get you twitchy and edgy then. So, yeah, we'll just start up a new tool here, which will be let's say level draw. So it's exporter. Naming things is hard. All right, so we'll come in here and let's just drop a quick virtual env. And let's install pillow because we're going to need pill. And let's import pill image. So we can use something like this and say, actually, you know what? I think I have a related tool. So why don't we start there rather than just go straight into some crazy code. All right, what did I have? Structify. I mean, this is pretty close. So I think we'll probably be better off just doing it this way. Let's just reuse this, right? And name will be title, and then this thing was really just file name. So the idea here is that I'm taking the image, loading it, turning it into a NumPy array, and then I can just step over all of the things. And I'm assuming that it's RGB in this code. So if I have something here, then I'm calling that a 1 and otherwise not, and then, you know, print that thing out. So let's run this and sort of see what it does before we go, because that's pretty close to what I'm going to want to do to pack the binary. So we'll take this with graphics and well, it was originally running with title, right? Except, of course, I didn't have a one of these, and then I can say if we'll go and pull sys in here, and then we'll say if sys argv is equal to 2, then do this thing. First, let's just make sure that we got what I think we got, which is this thing, and make sure we got the arguments, and you don't have NumPy in there, so we're going to go and add NumPy, and that gives us that, and title.png. All right, and that's basically what we want. So we'll just throw a quick note here. Usage, you know, this thing, image.png. And right. And we need to fix that. It's not 2, it's the length of this is 2. Come on, guy. All right, see, I haven't had as much coffee as Cam has, so I totally need to get there. I'm gonna up my caffeine a little bit. In honor of Arecibo, I'm hitting the Arecibo mug today. Those of you who don't know, snapped cable over at Arecibo. Sadness for astronomy. Let's get our sneezing ready. So yeah, I kicked up a bunch of dust earlier today, so that's gonna be fun. All right, so then in which case, if you do have 2 arguments, then make sure that you use the second argument. Sorry, I'm not doing any argument parsing today. All right, then this kicks out, you know, so we're thinking black and white here. We don't want it as hex, because this was, I was sort of doing it as a struct, but and I wasn't using XSC for some reason that day. But let's change this a little bit. So let's say that, okay, so that actually read the right file. So if I actually do this with level, then it still reads it in, and I can see in the corners here that I've got my ones going on diagonal, which is cool. Now I do need to make sure that this, okay, so this is actually just emitting it. Yeah, okay, so it's gonna do it however many rows we got. Right, so this, yeah, 31 rows, okay. So 30 because I've got the extra debugging output that I need to get rid of. 30. Okay, so there's my 30 by 32. 32 by 30, I should say. So let's pack that in binary instead of packing it like so. So here I'm, okay, it's building. I'm gonna actively watch now. That's fine because I'm just getting warmed up too, arrows and plots. So yeah, are you using a build cluster, by the way, or are you just going single machine crazy on it? It's not helping my ADD here. Okay, so we're gonna print out just value for a second. And don't show anything there. All right, so this gives us our bitmap in sort of just before the format we want to get this in. Nah, local single machine takes about an hour. Most of it is LLVM. Yeah, LLVM is a pretty monster compile, but solid compiler, right? So, all right. In this case, so if we want to build this thing as binary output, then we don't really want to write, I mean, we're going to need to collect like these bits one at a time. So let me just dump out what this thing looks like real fast. So yeah, it is in RGB. And I guess the only thing that's being written out is whether or not this is, let's go look at one of these. Let's look at the first one of those. Okay, so here's an example of this. So if I actually, you know what, let's just print out call real quick. Yeah, so you can see that lines where I'm getting a 1, I've got 255 in the alpha slot because they're all, I mean, RG and B are being set to 0, black, but if alpha is 0, then it doesn't show up. So that would be a transparent pixel versus alpha is 255, so it's actually a black pixel. So that's why we're looking at just call 3 to determine whether or not we want to have black or not. And in this case, I'm taking black is a 1 versus black is a 0, so that's kind of questionable. But we could flip these two values if we see that it looks kind of crazy on the other side. So can GPUs be used to decrease build times? I guess no. GPUs are effective for massively parallelizable. Compiling isn't really that. Yeah, using a GPU for so basically, just to add a little bit to that, like what a GPU is really slow at is branching kind of logic. So like typically on a GPU, you're trying to parallelize your calculation. Like it's usually cheaper to compute every possibility and then throw out the one that doesn't matter than it is to do like an if to find the one that matters and then, you know, take that, because that blocks the whole. It depends on the GPU obviously, but like take like an NVIDIA, like it'll have like those, like they have I forget what they call them, like CUDA blocks or something, and basically they like there's only one integer pipeline branching, like kind of like general instruction logic for the whole block. So the whole block kind of like has to stop and wait for that one thing to decide if there's like an if or something like that. So anything that's a state machine, like where it's like tons of ifs, like a compiler, is going to be really bad on a GPU. But there have been studies of like, can you do like string parsing faster on a GPU by just brute forcing it with all those parallel cores? And the answer is yes. Like, so it is probably possible, but it would, I don't think anybody in the world's done the right engineering to figure out how to turn that into a disgustingly parallel operation. I've seen some studies about strings, and I've seen like font calculations on GPUs, but I've never seen like something that's like basically just massive state machine, like a compiler done on a GPU. Well, I mean, so you'd end up like wasting more time like transferring it to the GPU and back. But so in that case, like an army of Raspberry Pi Zeros would actually outperform a lot, right? So like this is where like having like a distributed cluster, it gives you a really nice speed up, as long as like, you know, the compiling is fast relative to the transfer time, because you have to transfer the compile segment to the, you know, the other host. Yeah, plausible but not practical, and that's kind of the problem in general. Mythbusters, yeah, that's a great term. That's kind of the problem in general with like GPUs. You have to keep them lit, right? So, you know, memory bandwidth is always like, you know, one of your problems. So if you're spending all the time to get it over there and then like you're stalling the whole block in order to resolve one if, you know, like it, I don't know. We'd have to study it in more detail, but my intuition is that it probably wouldn't help. It's kind of my takeaway. So I agree with arrows and plots. It'd be hard to get that to work. Okay, but anyway, the GPU we have on an NES is the PPU, and it doesn't do anything like that. There's no branching on there at all. So it's just basically like you can load sprites, and you have some DMA there, and you can blit it out, and it's really good at that kind of like DMA type. I mean, I'm using the term blitter, but I mean it's a lot like the copper chip in a sense from the Amiga. So I spent a lot more time copper programming as a kid. So anyway, so we're just looking at this, and we understand this format. So we need to basically pack this, and we're going to need to assume that this is a power of 2 in order to do it. Actually, we're going to, no, not just a power of 2. It needs to be divisible by 8 because this is, we're gonna pack those as bytes basically. So, I mean, I guess we could, well, actually in my earlier calculation, I'm burning 1 byte per. Yeah, let's do the naive thing first. Okay, so let's just burn an entire byte per bit. So we're going to use 1 bit from each byte. So we're going to be very memory inefficient at the moment. So, okay, then this is actually basically right. So we just need to write that out to a file. So let's do, actually, I guess we could just pipe that to XXD, couldn't we? Let's see if I have some notes on XXD. Yeah, you know what? Let's just look at the man page. So this is like a C style include with -I. Octets per line. No. Octets as 8-digit ones and zeros instead of normal hextone. Each line is perceived. Yeah, that's pretty close, right? But we want the reverse operation, so convert hex into binary. Yeah, that seems like it would work. $20 as continuous hex. I don't want the headers on there, right? Yeah, memory is cheap in 2020, just burn it. Memory was not cheap in 1985, which is, this has to run on actual NES hardware, so, but we're gonna burn it anyway. So, I mean, we're burning a K, basically. You know what, I'm not even gonna screw around with XXD. Let's just write this thing. So, how did I get that? That shouldn't be there. So let's just, instead of doing the print, let's just with, well, let's say this is OS path join, file name, actually, you know what, you don't path join on the, because we're just adding, we're gonna add an extension. So we're going to make the binary version, write out binary, and this will be the file pointer. Take this thing, move it over, and instead of print, we're going, well, here, we'll print it out too, but we'll just do an FP write of value. And we don't need to give it any header, and we don't need any line stuff. I mean, we just want one continuous byte stream. Okay, so if we run that, then you need a bytes-like object, not int. Right, so it's a conversion, just bin. String. Oh no, that's not right. Bytes. What's my constructor on bytes? Bytes. Iterable of ints. Or you can just pass it in. Okay, fine. Let's do that. So we'll do bytes of value. Cool. Where's my file? Where did it just go? So it's going to be in the same place where I got it from because I used the same thing. So let's just look in graphics, and there's our bin file. So if we take a look at this thing, we got a lot of zeros. That's nice. Not exactly what I had in mind. So did I short circuit? No, that's actually, interesting. F. Nice. Not F. Yeah. I would take a not F on that. So is that actually writing out the right number of zeros? 44 bytes. No, it's not. Although, no, that's still wrong. Okay, so let's just hold this a second, and let's FP write just 8s. Let's see if we can get all zeros the right size. Then level 1 PNG dot bin. Okay, now we're getting nothing. Am I not allowed to write null bytes? Yeah. Oh, so that's lame. Well, how are we going to write a null byte then? So that doesn't make sense. Binary write. Yeah, I'm using it, but yeah, we opened it as binary, didn't we? Yeah, we definitely opened it as binary. Why is that? This is what I saw, struct pack. I mean, that would pack the whole thing, right? I was just writing it out one. Actually, I wonder if the write doesn't, let's screw this. So that's really like if I just grab a file handle to temp something, and I'm gonna add that to A, and I just say like, write the given buffer to the IO stream, returns the number of bytes written. So this should be that. So I'm guessing this doesn't like when I'm sending it as 0. So you know what? Let's just unroll that. Let's go the easy way and just say final, and that's just going to be an int array. And what we're going to do is we're going to just, instead of writing it as we go, let's just append that to append value. So I should end up with a int array of all the right values. Okay, which we do. So if we do that thing and we turn that into bytes, okay, now we're getting what looks like proper bytes. There's my one. Okay, so let's just write that out in a single write. So final dot, not final, fp dot write this thing. Okay. Yeah, okay. So if we look at this png.bin, okay, this time we have some ones in it. That's better. And the ones are in the corners. Ones are in the corners, which mostly, I mean, the line length isn't right, but that's okay. All right, so this is our binary. And let's just take this over to level 1 PNG bin. Let's move that into, it's no longer really a PNG, so let's level 1 bin. And let's come back here into source, and we'll just grab that level 1 bin and take it in here. All right, so great. Now we need to tell our assembler. So here's where I'm actually pulling in the tile stuff, and I'm including this in my character ROM. And if I load it in my character ROM, it's kind of where I want it to be. So we can play with the linker, but I think before we do that, let's see where this thing comes out in the memory map. All right, so if we take that and we don't worry about picopixel. So let's just make that real quick, and we should be good to go. So let's see if we get that in our ROM. Okay. Why are you not showing up here? There you are. Okay. So there's Bitboi Classic, and by the way, is it Math Fisher or Matt Fisher? I wasn't really sure the other day. What language are you using to write this? That was a little bit of Python I was just using for the bit packing, but we're going to be in C and assembly primarily. That was some assembly where I was doing the include, but all I'm doing in it right now is including the binary blob. So nothing interesting in assembly at the moment. So let's just take a quick look at our PPU viewer. And if we look on our character table, we see some dots. Okay, this is actually it right here. Now, because of the way the NES works, these planes, this is going to be just terribly memory wasteful if I keep going the way I'm going. So basically the way this works is it needs 2 bits per pixel. So what it does is it takes like the first 8x8, and then it takes the second 8x8 and it puts them together, and that's how you get 2 bits for each one of the pixels. So I show that if you're looking over here on, I guess you probably can't see that with the debugger up, but I'm showing that in some of the characters that I manually put in here. So I'll just get rid of this for a second. So this is like the front plane of a character, and then these are the bits corresponding to the back plane, and then if you put them on top of each other, so like this bit here and this bit here, you take those two, that together is the value of that pixel. So you get 4 colors. If you switch the palette, you can get more colors, but that's like the kind of basic version of doing an NES graphics. Math Fisher. Okay, cool. I'll try to say that right, Math Fisher. Definitely correct me if I get that wrong. So anyway, that's the reason why when I just pulled it up on the PPU, it looked like, which is our GPU on an NES, that's why it looks like this blue and red. I didn't actually set any colors, but because I didn't account for the fact that these need to be on top of each other. It's blending them to get the color. So like to prove that, what I could do, and this is where I started feeling really guilty about memory, is I could, so you know what we're gonna do? We're gonna specify an output file, output bin. So we're gonna require another argument because I don't want to get crafty with paths. And so we're going to do that, and we're going to say that this is no longer this thing bin. It's going to be file name, which is really in file name, and we'll just clean that up with in fn. Actually, you know what? Let's call that image. More descriptive. All right, so this will be the image file name, and then binary file name will be our output, and then we can get rid of this stuff, and that'll be where we write it to, and that's cool. So this thing gets sys that and argv that. Okay, so if we run that, then it should scream at me, yeah, you gotta specify an output binary file. So let's do that into source level1.bin. Okay, we're cool. So now let's change this. So to account for the fact that I've got 2 bit planes, let's just 0 the second one. So we'll only see a value in the first. So I'm wasting memory, which I probably don't have, but we'll deal with that a little bit later. So we're gonna append that. And then what we're going to do is we're going to append 0. So every other byte will be 0. So we run this, and oh, I'm sorry, I left the debugger up, my bad. So do that, and now it should be a little bit different. So I can come over here to my messin, and we can exit this. I'm just going to swap these terminals real quick. So we can make and make run. Yeah, sorry about that. I realized the PPU viewer was blocking a little too late. So yeah, now let's look at the PPU viewer. And we look at this memory, and oh, that didn't come in. So yeah, we're still seeing this blue top left, red bottom right, you know, and then here's like the next line, you know, kind of, and here's those lines that I was drawing out. So we're going to need to, that did not assemble right. So let's go back here for a second. And let's just look at tile. This is just including level1.bin, and level1.bin is now twice the size. Okay, actually did get the right size. So when I make that, looks like tiles did not rebuild. So let's get rid of tiles.o and make that again and make run it and take a quick look at the PPU. Okay, so this is right. So I do have a makefile bug here. So let's fix our makefile before we go any further, because that would be bad. Tiles.o depends on tiles.s, and now it also depends on level1.bin. Okay, so now when I touch the level1.bin, tiles actually gets rebuilt, which is what we want, right? This is cool. Okay, so all right, now this is now more right. More right, is that a thing? Can I be more right? Okay, you know what? I'm just realizing like what I was just doing to add like every other doesn't make much sense, because I'd need to do that on every one of these bits. Yeah, that would be crazy, because one of these tiles is 8 by 8. So if it's taking a byte, which it is, right? It's taking the byte as the top row. Then I would have to burn 64 bits going this route just to get one tile worth. All right, so that's crazy. So let's. All right, we tried the naive thing. That's being a little too naive. So let's stop doing that. Okay, but let's assume for a moment that this is in memory correctly. Let's not assume. Let's finish that. Let's actually get that, because this was the test run. All right, so we're not going to assume that. We're assuming nothing. We're gonna just get right in there and fix it. Actually, no, it's not in main. So we need to worry about our packing, and the way we need to do that is we need to ignore how it's going to look on the PPU, because we're not going to actually load it in the name table at all. What we're going to do is basically read a bit at a time. Actually, no, you know what? It doesn't really matter how it's displayed on the PPU. So actually I can burn. So basically, like in the PPU, I'm burning 16 bits per line because I've got two 8-bit planes. Which corresponds to a single value from my other drawing. So basically one of those lines corresponds to a byte of memory. So yeah, then what I need to do is read a byte of memory and place it. Okay, so that means that we need the offset to be able to start reading this thing in. Yeah, let's just go slow at first. So we'll worry about the other thing later. So right now I'm just filling everything, right? So let's just do a quick, let's not do that. Let's do a fill. We need a memory location, right? You know, we need something to fill from. And to do that, let's come in here. Let's go do Pico over again, and let's do it the way they do it. So we need the assembly offset of where this level is going to be, which actually we can just get the assembler to do that for us. Right. Yeah, this is my layout in memory. So tiles, tiles not in here. Because tiles gets included. Tiles is getting included here. So here I'm just assembling it. It's kind of dull. So we basically just want to export like the address of where that's going to be. So we just need a label, which is to say that it looks like, this ought to be interesting. So there's no dynamic labels in there. Let's take a dynamic label. Yeah, so like we want to export where this thing is. So yeah. yeah, let's just try that. So I've got tiles, which is this thing. And this is the segment. It's going to show up in the, it gets assembled into the characters. Yeah, I guess, you know what, an assembler directive here would really make life a lot easier. Like if we just labeled this. So yeah, this is where I forget the syntax. Oh yeah, just colon, right. Okay, so this will be the level. Level 1 location, right? So, and we can export that. All right, let's see how illegal that syntax is. Wow, that come on. All right, so that's neat. So now I should be able to refer to level 1 in here, which is extern. How do we want to refer to it? Let's just say unsigned care. Level 1. All right, so let's see if it finds that reference. It did. Okay, so let's try blitting it out. Okay, so we're going to get rid of that. We're just going to say for I is 0, I is less than 32 times 30. And we're going to just call VRAM fill. I know this is horribly inefficient. Bear with me. Of whatever's in memory at level, let's see, where were we? Level 1. And I think this is the repeat. So we're going to say just, I don't think you can say 0. I think you have to say 1. I forget. This is an off by 1 thing. So nestlib VRAM fill. Oh, there's actually a VRAM put. Yeah, let's use VRAM put. VRAM put. So, okay, well, we'll do that. So, VRAM put. So this should write a byte at a time onto the PPU. Anyone's guess if that works, but okay, so let's exit this out and no, close, exit. Okay, make result of comparison is constant 40. Can't do that? No, it isn't. I is changing. Perhaps I should not be mathing in there. Level size is going to be 32 by 30. Let's see if this compiler is a little different from. No, it really doesn't like that. Oh, you're absolutely right, Cam. I just forgot to write it. That's why. that would be the reason. Okay, so subscript value is neither an array nor a number. Huh. Let's just say that, and we'll just manually dereference it. I have a feeling I have a language issue there. Oh, level 1 is a pointer, right? Because we're offsetting to the memory location. So actually, you know what? That's probably my mistake with that. So let's put that back. Yeah, okay, that was my mistake. It's a pointer. It's not a value. So yeah, let's take a look at that. And if we no, stop that. Okay, we're writing all sorts of crazy stuff in memory now. So we're getting some nice visual glitching. Very nice. Okay, that's a step up. Before we do that, I think we're jumping too many steps here. So let's first test this out, which is to say, let's do a VRAM put of 0. So we're just going to do it the right number of times. And I think I forgot to compile. Oh, no, I did. It did do it. Huh. Okay, so flood filling it with 0. Flood filling it with 1. Well, we're getting blue. So I don't like that. Let me do this instead. Interesting. So that isn't doing what I think it does. Okay, so let's start with this. So this, yeah, my earlier question was, how many of these do you need to put? Like, is this a 0 count or 1 count kind of thing? So let's start with that. Okay, that seems like it's the right size. So let's change the tile. And I'm not seeing it. So let's take a look at the PPU real fast. And okay, that seems like it didn't quite write what we thought it would. So I was assuming it was going to write this, which is this checkerboard pattern, and it didn't. So before we worry about reading this memory and getting it written to the right place, let's worry about this. So we need to be able to get it so that it hits all of the locations before we worry about doing the mem copy. So let's start with all right, I'm going to get rid of this fill. And so we've got all the fills off. We basically have PPU off. We set which name table we're working with, and then we just start copying the thing out. So I wonder if the fact that that was off is called, nope, wasn't that. Okay. So, hi, also bye, because I have to drive. And what's up, Nightshade dude? Thanks for dropping by. And zoning feels, yeah, I hear you. Arrows and plots. Yeah, so something's not right there. Yeah, let's get back to working before we worry about this thing. And I have a feeling that that's okay. So we're probably overdrawing there. So let's just draw. Okay, first of all, let's stop all the crazy code we were just writing. And let's go with 2 fills. So that should get us yeah, this is kind of back to where we were before. And I don't want this. So for this, let's go. So you can't go to Python, right? Let's change this to tile 1 that we want to see blitted across for most of the lines. Okay, so that's kind of where we want to get to, is we want it to look like this. Except instead of that, we want to do it for the full value, which is, and we're going to just close that up. So instead, let's do 27 plus 11. This is I think I just have a math problem. Yep, we have some math issues. Okay, so that looks like it's overdrawing a little too much. Let's just take a quick look here. Yeah, all right. Now we need to worry about 36. How much do we have of visible? No, that's not it. Oh, Patu Muse, thank you for the follow. I appreciate it. This is now a Zorchenheimer stream. Nice. Yes. Nightshade, dude, I need to channel the NES Zork. I'm not sure what the short version of how to say his name is. Until we get this finished up for Trevor. So let's get our 88-bit music. All right, so we're writing out this thing, which is cool, but I have some math issues here. So we're going to get through my math issues. And that's not going to get us through our math issues. You know, I have a feeling I'm changing this thing, and I'm totally not making it. Am I making? Okay, cool. I am at least doing that. Let's do, so 32 by 30 was my original guess. And that is exactly the correct size. Okay, so now we're not overdrawing, we're not glitching. So if I do a little bit less, we're probably I'm gonna save that because good size math, dude. Okay, so we're gonna watch our math here. So if we underdraw the screen a little bit, yeah, okay, so we see some lines disappear off the bottom, which is what we want to see. So are you going to grow your hair out? Also asking the real questions now. Nice one, Nightshade, dude. I have been growing it. Still staying in isolation, kind of taking care of some elderly folks, and they're definitely at risk. So I've been growing the hair kind of crazy. But fortunately, it doesn't grow that fast for me in this case. So great. If we flip what we're drawing, so if we take like the next, if we took that, I think the arrow was the next tile in the map, then yep, there's the arrow up. So we can see that this is pretty good, and we're cutting off those two lines that I expected at the bottom. So let's go and throw those back on. So we did have our size calculation right. Okay, the NES definitely will get upset if you don't, if you get your memory wrong, right? If you get your memory sizing wrong. So let's try stepping this down. So let's just do a row, and that's going to leave the PPU in kind of a crazy state. So I haven't cleared the screen, but I am getting one row, which is cool. And if I back that off to just this, then I get my single arrow in the top left corner. Okay, so this seems to be right. And I'd love to know what was wrong with that before. But if we come here and we do, so that's going to write one at a time. And if I write out 32, all right, I think that was probably my math error there. Then, yeah, there's a single row doing it with my loop syntax. And then from there, so it was good that we went back to a working case instead of screwing around, wondering if it was our level or our output or something like that. Okay, so if I write one of those and I just do this a single time on my loop, then we should reduce that to just a single up arrow, which is cool. All right, so now we don't actually want to write that. Let's blank the screen. So we're going to do that, and that didn't blank the screen at all because we're only writing one of these at a time. So here, let's try our level size number again and see if it was that. Yeah, that's causes the error. So it was that. I don't know why. That's kind of screwy, isn't it? So let's not do the math in the compiler. Let's do this, which is our 960 number. So let's just say this is 960. Okay, and that actually glitches. So does 900 glitch? Yeah, it does. All right, interesting. So let's go back to up arrows for a second, and let's just do this a step at a time here. Okay, so there's our single line, and is it because it's like, oh wow, okay, so that blew it out. Huh. So 320 would be 10 lines. Wow. Screwy. Okay, I'm out. Catch you later. See you later, Nightshade dude. Do you have to deal with the overscan area? Yeah, you do. But what's odd about this So I think we have a leaky abstraction here. First of all, let's get rid of that. And what's worrying me is this warning that we're getting, which is result of comparison is constant. So let's get a sense of like, is it when it goes past a line that it breaks? No. Okay, that's actually fine. And is it something like this? No, we're still good. So yeah, we're still good. That's really weird. So 400 were busted. So somewhere between 200 and 400, this isn't happy. Which is probably related to how many... Oh, what am I thinking? It's an unsigned... It's a byte! You can't go past 255! Oh, man. Okay. That's just... So that's oh god, the iterative way of finding out that I declared a byte. That's wonderful. That makes me happy. I'm sorry I tortured all of you with that. But I was like, are we running too many instructions while the PPU are we getting some weird glitching thing? I'm thinking all these like crazy things, and it's like, yeah, you're overflowing a byte. That's why your comparison. That's why we were seeing comparison is constant, because it was like it can't wrap around on the 300. Oh man, I feel like an idiot. All right, progress is progress. Cheers, everybody. apparently I did not have my coffee quota to be putting my head into 8-bit world, NES world, thinking about 8-bit values being large. There's always that mind shift when you really get back into NES programming. But anyway, all right. So now we know why that doesn't work. That's wonderful. Bad guy. I'm going to give myself a bad guy. Bad guy. Watch the max. Watch uint 8 max. All right. So, cool. Now, so the next question is really like, all right, how many blitz do we need to really do this? And the reality is, well, so first of all, let's start with, now that we're not glitching, let's go back to our level code and start worrying about that. And I'm just gonna close this real quick. And no, don't do that. Why would you do that? Don't do that. Okay, cool. So we're gonna make that, and we're gonna come in here. Okay, it's now we're getting some nice junk. Nice. We're copying a little bit of our sprite table, and that feels good. Okay, so what we don't want is that. We want the right offset for level 1. And you know what? Let's just be sneak about it for a second. And let's come in here and just take a quick look. I can worry about how to get it to link it and figure this number out for me. But for right now, I can also just look in the viewer and say that this starts on tile 83. And actually, that's kind of our next problem, because this routine is copying a tile. Yeah, okay, so you can't do that, right? Because if we copy the tile, like it's always going to be a byte. Like we would only want to copy like the top line, right? These 8 bits, which I don't think you can do with. I mean, you can't write that as a byte to the PPU. Like it's writing out this whole thing. It's actually writing out the address of where these 64 bits are, and the PPU is taking this plus the next chunk, and that's what we're writing on that call. So we don't want that at all. We want to be able to write directly onto. We want to be able to write the tile value directly onto the PPU, which is probably closer to this. So let's not do that. Let's do VRAM put 1. So we're back to our, we want to see the checkerboard showing up. Okay, so our checkerboard is showing up. That's cool. And just to make sure that I'm not kidding myself, we're going to change that to the up arrow. And we do that, and we're cool because, yeah, there's up arrows. All right. This lets us specify which byte, which tile number to use. So what we can do is we can use that to read the binary data, and then it's our job to kind of turn that into which tile to show. And that's okay. So I mean, that's how bit by bit. So we definitely want to do that in assembly. But yeah, that what we could do is we could kind of like read a byte and then write 1, and then read a byte and then write 1. That's the slow way of doing it, right? I mean, I know that there's an optimized mem copy in here. And so I'm just glad I realized what was happening before you did. It makes you feel like I'm like, nice, Cam. World built in 3,590 seconds. 12 CPUs, make with J15. I like that you're over subscribing the CPUs by a little bit. That's a pro move right there. So that's about, yeah, you're 10 seconds shy of an hour. That's awesome. I mean, for the full, I'm assuming you're not just doing the kernel. I mean, you're doing like the full OS there. Nice. That's pretty fast machine you got there, alts and plots. Okay. Oh, okay. Cool. I can't even think. It's been a lot of years since I've built FreeBSD from source. Yeah, I mean, it's tiny compared to like all those other. I mean, there's a lot of stuff you got to build. So just to put that in perspective, the last time I really spent time with FreeBSD, it was CVS up to get your latest. That was like kind of insane. Like just downloading it was a bit of a challenge. They're like, oh, we could do a lot better than CVS with a little bit of server time. It's like, anyway. No, it wasn't CVS. It was CVS up. This was like built by this professor, and it was in a screwy language. Like, it wasn't a mainstream language. So you had to like first get the compiler to work for that language. It wasn't like OCaml or something. I mean, it was like something like really off the beaten path that CVS up was written in. Anyway, that getting distracted. But anyway, that was like the primary way that you would sync your ports tree back then. And so it's been a while. Okay. So, right. Let's see. So this is kind of writing out. That's cool. Let's write out a little bit more. So this approach is kind of the wrong approach. Because this is already in the name table. I mean, what I could do, that seems really bad, actually. So we're not going to do that. That's okay. We're not going to do that. So let's write like a let's look at a moment at how this is getting assembled. So cares is actually where the name table is getting assembled in. And the template that I've got is that cares sort of starts here, and it's getting mapped. That's non-consecutive. So what I can kind of do is, yeah, because this is actually loading it onto the care ROM versus the program ROM. So that means that I'm going to force a fetch to the character, because what I'm going to need to do basically on the NES is I'm going to need to, if I leave it there, I'm loading it onto CPU, the 6502, and then I'm writing it back to the PPU. So it's kind of like coming off the character ROM into main, and then it's sort of writing it back over, which is not good. So another way to do that would be to assemble it into like the data segment, which is on the prog ROM, which will get loaded into RAM. So it'll basically be at a RAM offset, which is kind of the way I was sort of like starting to write it before. It's not sitting on the name table like on the PPU memory where the care ROM is normally loaded. But that means we need to get it to like show up in the right sort of place. So I think the data segment is probably, yeah. I shouldn't just override. Yeah, segment data. So that's showing up in main segment data. Yeah, so, and that's where the RLE is getting, so this is actually what's going into main memory. So what's nice about CC65 is that sort of by default, it drops the assembly. So if you have like a C program, it drops the assembly and then it assembles it, and then you get the actual like byte code, right? So if you look at like this, yeah, you're getting, this is, you know, it's a CC65 object, the intermediate link object, as opposed to like the final compiled NES ROM, which, you know, it's put the care in the prog banks and it's selected the right mappers. There's a little bit of a header in there. So what we would want is sort of like the way this title RLE is being placed right in the data chunk. So we can kind of see like what it's doing. So here's the data segment, and this is the stuff that's run length encoded, and here's a bunch of the these are the variables that I'm using. This is a bunch of stuff that I have like initialized, and this has some more stuff in there, and then here's the code segment. So this stuff is getting mapped early into memory. So what we can do, I mean, the naive thing to do is to just turn it into a struct. Just turn it into a byte array, you know, a pre-initialized byte array for the compiler, and then it'll show up in C land sort of naturally. That's kind of annoying. I mean, because I guess I don't really want to screw around with the link script for ages. So let's just do that because that's actually something that XXD can do just fine. So like what you can do is you can take this binary chunk, which is this level 1 bin. So I can do like an XXD -I level1.bin, and this will turn it into a C structure. So here's my level 1 binary, and shows up as unsigned char, and then it also comes through here with whatever the size is that it's taking up in memory. So now that we know that we don't want to write onto the PPU, I'm going to change the packer a little bit. We're not going to append the extra 0. So let's do that. So we rebuild that, and that ends up on the binary. And then if we rerun this, yeah, now it's 960. So what I can do is I can take that and I can output it to, so obviously this isn't going to scale, so we are going to have to do this like bit by bit. But better to get to that problem first. So we'll put that into level 1 bin.h, and I'm going to learn how to spell someday. This is not that day. So we're not going to do a leave. We're going to do a level 1. All right, cool. So we write that out. We end up with level 1 bin.h. Okay. Now we can close this. Actually, you know what we're going to do is we're going to put that back because I'm going to remove it from here, because right now I'm putting it onto the PPU memory, which is not really where we want it to be. So let's go back here and include level 1 bin.h, and let's see if that blows out our available memory so we get a link error. Yep. Okay, so I said we could try to be naive until we actually cause trouble, and we have caused trouble. So this has overflowed the size of the prog ROM by 49 bytes. So we don't get that sloppy. We actually are going to have to start programming this correctly. Fine. Well, that's what we're going to learn. So this thing, I mean, the easy thing to do, this should divide by, actually, let's not make any assumptions here. So if we take like 960 and we divide by 32, actually, so 960 divided by 8, we're okay. So we need to burn 128 bytes of memory if we bit pack. So let's bit pack. And the way we're going to bitpack is we're going to do that in Python. Right, so we're just going to do this 8 at a time, and we're going to assume that it's always a multiple of 8. So let's just throw a quick warning in there. After reading this in, if Emma, actually here, let me print out the length of this thing. I forget if you have to like convert it first. 30, okay. Wait a minute, that's not the right number. Because if we have a row and the column in row, okay, so that's actually, it's not length. That's because it's a multi-dimensional array. So we would need to, what is it, 2 array? It's not 2 array. Yeah, we have to do that like NumPy, like unfold thing. Was it slice? Yeah, my NumPy is definitely rusty. Well, what we could do, actually, you know what? I'm going to be lazy today. We're going to take the row and column because we're actually counting right there, so we can just count it. So final actually has all of the elements in it, and what we could do is, this is writing it out, but we could say if length of final is not divisible by 8 cleanly, then raise exception not image bytes not divisible by 8. All right, so if we do that, yeah, okay. So length of final, let me just take a quick look. Length of final 960. What? Divides just fine. What are you talking about? This thing mod 8 is what? 0? Oh, if it's equal to 0, come on. All right, if it's not equal to 0. Right, okay. Not sure I should be coding assembly and 6502 today. My brain seems to be elsewhere. Okay, so we know that this thing is going to be evenly divisible by 8. So what we can do is we can like byte pack, and that's where actually the structify that Cam mentioned before is probably going to be a better way to go. Kernel generic built in 168 seconds. Nice. That's that's pretty fast. It's not long to wait. That's pretty reasonable considering how many lines of code like the FreeBSD kernel probably is. Okay, so we know that this is divisible by 8. Let's struct pack. So we're gonna go into Python and struct, and let's just look at struct. One of these formats is yeah, I mean, like what we want to do is get out bytes from a group of 8. You know what? That's not going to help us. Let's just shift it on. So is that crazy? Ugh, I don't know. I don't know if I trust my thinking today. Okay, let's just do you know, NumPy Actually, we're collecting these a bit at a time, so we could do it right here, right? That's going to be bit reversed. Because the problem is you can't left shift. If it starts with a 0, you can't left shift it, because you're going to shift 0. It's going to end up being 0. So, well, now the pain of installing all that is away. Yeah, that sounds like pain. It's like the pain of me about to compute this thing. I feel your pain, Arrow, or at least I feel pain. I don't know if it's the same pain that you're going to feel getting this to work on a Raspberry Pi, but still pretty cool to build the full system. So yeah, let's just, all right. What I'm thinking is we basically shift right to left to guarantee that if we start off with a 0, it gets slotted right. The one catch, yeah, you know what? Python's a really bad language for that, isn't it? You know what? Let's pull this out of here because I don't want to do it in the same routine. That's kind of crazy. What we should do is let's just pass up the array of integers, and then we'll worry about packing it in the other routine so that I can not try to do everything all at once. Pack as bytes, and we're going to take the final in here, and we'll also take the binary in file name and final. So we'll just do a quick pass on there. And this is not going to do this anymore. So this will do this. And this will all move over here, except that this is going to come. Well, we can leave that in there, but this we're going to move down here. All right, cool. And let's just do pack as bytes with bin that thing. All right, so let's have our separate programming problem. So we have an integer array that we need to spit out to the file. So let's just start real quick with looking at what we have. Okay, so we have an array of these, and what we want to do is grab groups of 8, which NumPy has that handy routine, which I need to use the right version of NumPy. NumPy is numpy dot. It's that, what is it? Group. It like splits into bins. Bin. No. Done this before and I just totally can't remember. See if I have a note for it. I always forget the name of that function. That looks like NumPy. Basically, I just want to like stripe it. Is it slice? Or that's an attribute of the array. From not what I thought. I haven't worked with NumPy in a while. Yeah, there's a quick NumPy. Oh, you know what? I did it on CSG Flicks. That's where I did it. Let's just take a look. And encoding, one of these is going to use NumPy. Encoding does. And so you just do array. All right, that gets you a NumPy array. So array 1, 2, 3, and it's gonna be a dot. Is it resize? New shape, tuple of ints. Right. So if we make like groups of 8, this would be the right way to go. So let's just say that this is going to be numpy dot array of final. So we have a numpy array, and we can do a resize, and it takes a tuple. So I think you can specify 0 as one of these. Shape of the resized array. Let's see what that does. No. Yeah, it's not resize. NumPy reshape array. Is it reshape? -1. Yeah, this is the one that I want. Reshape. Okay. Reshape. Okay, and this is at the NumPy level. So reshape A to be this. And let's just look at that. And then we're going to make this dimension free. Shape is not defined. It's not reshape. NumPy reshape. Okay. Okay, there we go. There's our groups of 8 that we want. And what we need to do is basically just shift these on one at a time. And actually, this would be like a nice pack thing. But, well, we're going to suffer because Ots and Plots is suffering. I'm going to suffer with him. So that's new here. What is the project? Mustafa El Sayed. This is a, I'm doing a little NES, so forget this at the moment. You caught me in the middle of binary packing in Python, but I'm building a NES game, which is currently overflowing in memory. So what we're doing is we're packing the level data so that it fits into the program memory that we have on the NES. So yeah, okay. Imagine using the tools available to the original devs to do this would be terrible. Oh, and thanks for the follow. Appreciate it, Mustafa El Sayed. Yeah, I mean, it just, Cam, they would be doing a lot more of this in their head. Like, I'm super rusty with this, and I haven't worked with binary in Python, or, you know, and I'm definitely rusty on my my C interop with assembly and 6502. So this is like 10. I guess I should just put up live learn at this point because it's been too long for me with the NES. But I mean, with the original tools, like, it was a lot more. So getting a dev system was kind of hard. The PPU, the debugger that's available in Messen is fantastic. But anyway, so Mustafa, where we just got to is I've taken my level data, which I originally drew in Pixel Editor, and I've got it repacked as groups of 8 bits, but they're actually 8 integers. So what I need to do is I need to take those 8 integers and get them to be a single byte. So we're going to just read these, right? So actually, you know, there's only 8 of them. It's not like this is super painful. Now that I've got them in the right shape, I could just say like for byte worth in B, then we can just take a byte worth of data. You like what I did there? And show it. Okay, great. So if we take a byte worth, then all we need to really do is just say that this is going to be byte worth. That's going to be a lot of typing. So we're going to change byte worth to BW. And we're going to say that BW sub 0, this is going to be my 0 bit. What I'm going to do is I'm going to add to it, because we don't really care about the runtime of the Python program that's going to be packing this data. Like, we care about the NES runtime, if anything. And then we're going to take this and we're just going to, whoops, don't do that. We're going to, whoops, we're going to do this and we're going to shift it over 1. And we're going to do that and we're going to shift it over 2. Since I think that's low precedence, I'm going to be just careful. And if I do one more, then like BW3, shift it over 3, and I add that, then I can just copy this, and we've got pretty much what we need. So we're just going to change that to 7, 7. Of course, I'm going to have an off by 1 on this, so we're gonna test ourselves momentarily. And 5 and 4, and that one we have to shift over 4 and whatever. Okay, and we get to be lazy and not write it in a loop. Okay, so this would be the final. Is not, no, we're already using final. The byte is that, and we can print that out, and we can print out the byte. Except this needs to be a hex value. I don't want it to actually show up. Okay, you're not allowed to, yeah, come on, line continuation. All right, Python. There we go. Okay, so let's check how we did with our binary arithmetic. It looks like we're reversed. So the one with that is the big number, and the one with this is the small number. So it looks like I got this backwards. Nice. That's what you get. Whoa! Subscription from Math Fisher. Thank you, Math Fisher. You have some of the greatest programming emotes on Twitch, in my opinion. You have access to the no regex version. Okay, play the oboe. Wow. I think bool type should work, right? Oh, I didn't even think about that. We have a bool. I mean, can you just specify a bunch of... No, you can't. All right, so that's like a single bit, right? Like bool of like true would be like that kind of thing. I'm trying not to be clever at this point because I got bit too many times so far in this stream. So what I'm going to do is I'm going to reverse these. I'm going to say that this is 1 and this is... I'm going to say this is 2. And this is 3. That's 4. Oops. And that's 5. Oh, whoa, don't do that. And that is 6. And that is 7. Okay. So let's see if we got that math right this time. Okay, so this time the 1 all 0 shows up kind of in the byte order. So I realize I'm imposing my big Endianness on this by putting the 1 on the left over here. But we're going to deal with it because I feel like being big Endian today. And so the 1 ends up being over here, and the 40, this ends up being kind of where we think it's going to be. Okay, and actually, if we want to be really careful, we can also look at it in as binary. So just to make sure that we're shifted right. Okay, so 4. Okay, so in the maximum value, we're good. And yeah, is there one where I think later on I did some, okay, yeah, so here's like a nice one. So here we did, that turns into F0. Okay, cool. So we managed to write this correctly. Sweet. Love the content, man. Last Miles brought me here. Really cool stream. I appreciate that, Math Fisher. I definitely do. And thank you for the sub. So, yeah, so for Mustafa, anyone who's just dropped in, usually like math is probably referring to Tuesday nights. I do learn sessions. I teach people, but I teach people stuff that I know really well, as opposed to experimenting more with like NES or whatever that might happen on different days. So Tuesday nights is pretty regular, and I'm going to be switching to a regular schedule. So right now it's still up in the air. People vote on Discord if you want, but I should put a little poll in there. But it looks like it's going to be probably Tuesday night, Thursday. Tuesday night's fixed because Jesse's only free sometimes. Thursday, I think night, and Saturday afternoon seems to be the split. But maybe I'll do Friday, maybe I'll do Wednesday. I'm not really sure. So still playing with the dates, but I want to get regular about when I'm streaming. Okay, so that's sweet. Let's so we got that byte packed. So actually we didn't actually pack it. What we did was we figured out how to convert it properly to binary, well, to hex in this case. So we can actually write that out, which we can do right here. We'll just say fp write that byte, a byte worth of data. Actually, we don't want the byte worth, we want the byte. All right, so we'll just write a byte at a time. We don't care about being efficient on this. All right, so stuff happens, and yay. I'll leave some debugging in there. I'm not really sure where that other print came from. Yeah, what's that initial? This is why I hate when I write like a print and okay, that's this. I was testing the thing. Okay, so that's what that came from. Cool. So let's get rid of that. Can you define night and afternoon roughly? Cam, I'm actually going to put the schedule after we talk it out on Discord. I'm just going to post it on the stream here. So the rough time that I'm thinking is afternoon is either 1 or 2, 1 through, like start at 1 to 2 p.m. Eastern is afternoon, and start at 7 p.m. Eastern is night. I found that the 7 p.m. seems to work really well. Well, Jesse and I usually start like a half hour before the stream just to kind of warm up. And again, some of this is like, I think let's just talk that out on Discord. Figure, because I've got a little bit of flexibility, but I do want to start. I want to post a schedule so that it's like gonna up the game on my streaming. So, and I think that means being at a certain time. So, all right, let's do. What was I doing here? I was writing out bytes, and we wrote out bytes. So this would have shown up in the other file if we got it right. Which, let's just take a look at what we got here. Level 1 dot bin. Okay, and so here's the 80, and here's the 40, and some of the other numbers that were shown up. Okay, so it looks like this wrote out correctly. So we can do an XXD. We can turn this from raw binary into a C header. Level 1 bin H. So if we go and look at level 1 bin H, then this has my bytes written out in a nice C includable header. Okay, so now I pull that in, I remake the whole thing. Memory overflow, man. Wait a minute, okay, so something's definitely wrong here because that should have been a lot less size than the other one. Okay, I'm gonna think about that in a second. So later streams are better for me, but I am one of many. College happened last semester when you were streaming. We'll be the same this one. Okay, that's cool. Yeah, I mean, I feel like starting at 7, you know, like the first half hour, I'm usually just getting into the code zone anyway. So like, I mean, that means that like really the stream's starting at like 8 Eastern. And I've been doing a lot of like 8 to midnight kind of stuff. So that probably fits the night session. Mustafa, not that technical question, but how do you switch between Vim and Terminal that fast? Is it Tmux? I'm actually using Screen. No, I'm not using i3. I used to use i3 a long time ago. I haven't used it. Primagen's using i3 now, I think. But yeah, I'm using this is just regular Screen. And you'll occasionally see me do things like split windows, and you know, this is here I can split my screen, and so you know, Tmux does all this stuff. So if you're familiar with Tmux, I mean, it's Tmux was like I'm just like when I first tried out Tmux, I'd been using Screen for a while, and the Control B threw me off, and I just never bothered to remap it. So like that's my whole history with Tmux ended very quickly just because of a Control key. So I want to get back into Tmux, and part of the reason I tried it out in the first place was because it was a lot more memory efficient. So back then, my assumption was I jump around on a lot of different machines for work and stuff like that, and I sort of assume nothing about my setup, my work setup. So Screen tends to be installed everywhere, and it's been that way for a long time. Tmux, I haven't surveyed it recently. When I checked it last time, Tmux was not part of a lot of stuff, but I'm guessing that it's probably in base distros by now. So also Tmux can't handle serial terminals, and it is nice that Screen can act as a terminal emulator and just write straight out. I mean, so it's I have nothing against Tmux. It's just like I had a Control B, Control A problem. And yeah, I mean, I think it's just familiarity at this point. I've just been using Screen for a long time. And I understand Screen finally did add vertical splits, but I think I never used them. They just weren't there. That was like the killer feature on Tmux for a long time, was they had vertical splits. And I was like, whoa, we can split vertically? I always just start another session. But anyway, and if you want to see my Screen stuff, I think I have dot files, which renders a lot better on Discord than it does on Twitch. So sorry about that. I've got my Vim RC in there because people ask occasionally. I have very, very minimal Vim just because who knows what's on a machine. And actually you can get most of my Vim just from that set line that's really all jumbled together. So I could just do the set and the IMAP and I'm pretty much good. So I'll just type that out sometimes. As for the Screen stuff, the Screen prompt is a little bit crazy, but that's in there too. So it's installed. Let's hope I won't need Screen in a serial adapter. Yeah. This is a case where like needing a serial adapter usually means big trouble. Like when you're working on an OS. Okay. So we're going back to unsplitting this screen. And so, by the way, down here you can see like kind of my screens that and when I'm a good dev, I label them, right? So this should be labeled like the text, this is the code. And this should be labeled like this is the build. And that would be better because then you can kind of see which window I'm on here. All right, so yeah, where were we? We were building something, and that's right. Okay, so this was screwy. It was not using, okay, and that looks like it might be because of reasons. So let's just delete level 1 bin. And when I looked at level 1 bin, the binary, it's exactly 960 bytes. which for 32 by 30 is wrong, because that shouldn't be 960 bytes, because what we've done is we've packed them all into bytes. We've taken 8 bits and we've rolled them into bytes. This should be 120 bytes. So it looks like that's probably bad. So let's go back to our this thing, and I don't open. Yeah, okay, so the only write is in here. And here I'm writing out the byte. Okay, let me see. How big is this thing? 120. Okay, so it should be 120. And when I look at it, the only thing that I'm writing out should be this last one. So I'm going to close that. I'm just going to write out the raw byte, which Python will probably throw up at me. Okay, so that's actually the byte. And how many of those are? There's 120, which is correct. So did I write it to the wrong file? Let me get rid of level 1 bin here, and let's go and write that. And let's just take a look at level 1 bin 960. Okay, so it's definitely writing out way too much. And that might be because this thing again. And that's going to have that same 0 problem that we just encountered before. So what we're going to do is we're going to use the same trick again. We're just going to stick them all in another array. This could obviously be a comprehension, but whatever. So we're going to say result bytes. And we're just going to take this thing, and we're going to just append to result bytes the bytes. And that way I can get one single write bytes of result bytes. All right, so let's go do that. Run it again, 120. And if I look at the size of this file, it's 120 bytes, which is what we expected. And now when we build it, the file doesn't exist because I forgot to do level 1 bin into level 1 bin, because I need to turn this into a C header that we can include. So this will be level 1 bin.h. And if we look at this, it should now be a more appropriate size. Okay, so it's like 800. Before it was a lot bigger than that. So this thing is 120 bytes. Okay, so now if I make it, yay, it builds. All right, it fits into memory. And look at that, our alts and plots thing worked at the same time my thing worked. We were totally in sync, arrows and plots. We were in pain at the same time. We were getting code to work at the same time. Man, it's just like the ESP is strong today. All right, so that's fantastic. We have Nico at Triton, and running on AArch. You got your ARM64 version. That's awesome. Too bad it's FreeBSD and we can't take a look at your proc CPU info because it's FreeBSD. You don't have any BOGO MIPS? Come on, where's your BOGO MIPS? Yeah. Yeah, and that's Mustafa. Most of the stuff that I write on the show ends up getting open sourced up there. So you can check that out. I open sourced the multi-user pad that I do lesson content where I want to move multi-user pad into being a hacker tool instead of just a learning tool. So that's kind of next step. If you want to take a quick look at that, it's got glaring security holes, so I don't recommend you run it yet. But multi-user pad, and this is what it looks like. And for the C lesson, so you got your coding area. This is, you know, kind of like a Google Docs type window where multiple people can edit. This is for the whiteboard sharing, and this is for Nightshade Dude's not here, so I call it a whiteboard, even though it's black. And we can do a output window over here on the left. So what I want to do on sort of hacker mode of this is like make it so multiple editors will be on the screen, and, you know, I don't know, resources can be shared. So anyway, that we'll get to that in a future stream. Not today. We're dealing with the NES today. Okay, so right, this thing. So we got it to assemble. That doesn't mean that it works. So we're going to do our make and our make run. And we take a look at this, and right, we're back to where we were. Okay, so our NES stuff is coming up, and now we should have a reference to it in memory to work with, which is this thing. So now I can just refer directly. I don't have to worry about the segment anymore. I can worry about whatever variable XXD pack this in, which is level 1 bin. And they write the length out too, which is really nice, except that length would be too big. So let's let the compiler do the work for now and bump this up to an int, and let's do, this is going to be a level 1. What was that? Let's see, I was in, not tiles, I was in level 1. What is this sort order? Okay, so it was here, it was level 1 bin len. Okay, and this would put out the whole byte, which is not exactly what we want. We want to do some bit stuff here. Can't get root, at least over SSH. That error alts and plots, I've done that more times than I can count. Like that's why it's always handy to have that serial adapter handy. I've got one over there for magic modem work. And SU doesn't have set UID. Yeah, it's just, that happens all the time to me. It's always a couple reboots before I get a usable system. I'm like, should I mount it? Should I fix it? Nah, just rebuild it, you know, whatever. Yeah, that's the fun stuff. I hear you. Okay, so what we can do is this times 8 is basically how big the screen is. And so we should be able to write out the whole screen, which is correct. And now what we need to do is take each byte and unroll it. So we're not going to multiply by 8. What we're going to do is we're going to take each of these bytes, which are in level 1 bin, and we are going to shift them off one at a time and write out whether it's black or not. So we've got reversed. So we have a 1 for when it's black, and we have a 0 for when it's not black. So let's just manually unroll. Well, we could just unroll the loop, right? So it's basically this thing. And can we specify it this way? If this is actually easier in assembly than it is in C. So if it's this thing, if that bit greater than 0, then actually what we want is just not of that. Actually, no, we care if it's 0 or not, right? So if this thing is equal to 0, let me not get fancy because I've gotten myself in enough trouble today. if this thing is 0, then there's actually, I've got that. Yeah, the black is actually means that there's something there, which is going to show up as white on the screen because we need something for the player to stand on. So if it's 0, we want to show up with nothing. So we're just going to VRAM put 0. Otherwise, VRAM put, well, let's use the up arrow to signify that there's something there. That'll work. We can be a little more crafty about this, but let's just worry about the first bit for the moment. Let's get the first bit working. Okay, it looks like the first bit is not working. Okay, so this thing, that's not, I'm thinking bitwise, what am I doing? That's why you do one at a time here. Okay, so that's another problem. So let's see that this, oh, actually, wait a minute. If it's not set, then wait, so that means I'm reversing, I'm getting my logic backwards. Like, so in this case, it's not set, right? This bit would be set with, yeah, this bit would be set if it was like F0, for example. So let's fix that for a second. Yeah, see, I don't think it's hitting that right. So yeah, let's throw this back to the right value before I forget what it's supposed to be. Oh, wait, I did it again. Wait, we're not doing anything else. We learned the hard way that that was bad. Okay, so int, I guess, is not big enough. So to get a 16-bit, it looks like we got to do like a, it can't be a long, right? No good. Okay, so 120. Actually, 120 is small enough that it should have worked. Wait a minute. Oh, this is the problem line. Okay. So, do I have too many digits here? It's 8. Is that the binary syntax? No. Okay. Yeah, I had it right. Okay. So, level 1 bin. Oh. Chris Chick. Thank you for the follow. I appreciate it. Let's see. This was... Huh. Well, let's just shift and have fun. Yeah, I don't want to start that in assembly right now. That's just crazy. All right, so this thing and that thing. Let's reverse our logic. I'm not sure why that's rolling over. Result of the comparison is constant. Okay, so level 1 bin, what type are you? Unsigned care. That's an unsigned care, this thing. Let's just isolate this for a second. Let's say that this is okay, so that's definitely set, right? So if I AND it, yeah. Result of the comparison is still no. All right, so if I AND it with, okay, this is equivalent to, let's see, that's 0, 1, 2, 3. 3 is 8, right? So that's working hex. No. Whoa, am I crazy? Cam, it is supposed to be plus increment 1 because what I'm gonna do is I'm gonna do all the bits. So we're gonna do like a byte at a time. But right now, like the first bit isn't even working. Let me start at the other end. Let me start at the least significant bit. So if that happens, this case it is constant, right? So if this is, let's get our logic right. So in this case, it's true, right? I'm ANDing it, 1 and 1 are both set. So it's equal to 1 when I AND it, and that's 1 is not equal to 0, no. So I should get a black tile. Let's reverse that. Let's go with the arrow here and the black tile here. So if I run this and I take a look at it, it blacks out the top, which this is the black case here. But actually that's not really what I want, is it? We want the other way around, because we want, when the bit is set, we want to put something there. Okay, the bit is set, we want to put something there. Cool. So let's say this looks at level 1 and that thing. Oops. Level 1 bin. And okay, so now we're getting a couple of these, which kind of makes a little bit more sense. So here, the first one we get, it is 1. Okay, so this is right. Okay, so we're working right on the lowest bit. Okay. Fix this set UID thing. 112.15 baud are awesome. 112.500. Don't you mean 115.2? I've got too much math in my head right now. I've been so rusty with numbers that I'm paying for it. So, oh, okay, cool. Yeah, I'm like, wow, I can't get any numbers right. I don't even remember my BPS speeds. So, excuse me. Okay, so let's keep bit banging here. So this, we're looking at the top bit. And what I'm thinking is I'm just going to manually like unroll this, but let's not manually. Let's write prettier code and just unroll it later. I'll just do a to do unroll this later. Okay, so that means we need another counter. So let's grab. All right, so we're gonna get rid of that, and let's just do another j is 0. Okay, so for j is 0 and j is less than 8, increment j. All right, so take this over. Let's get rid of these and throw that there. Then 8 times, let's evaluate this, except that this is going to be the changing thing, right? So we're going to look at each bit one at a time. Okay, so it's really one shifted. Actually, let's go the other way, right? So we want like the high bit. I'll just set all the bits, and oh, you can't do that, can you? No, we just want the high bit. So the high bit set is 80, right? Yeah, 7 would be all bits in the word. 8's the next one. No, it's not. Okay, so the high bit is 2 to the 7th, so 128, which there's 2 digits. So, oh, it's the 7. Yeah, all right. Duh. So let's check the math, because I'm not trusting my math today. That I'm going to have to go ahead and I'm going to throw up a regular calculator. We're going to look at the programming, go into programming mode. Let's just see if I want one. Okay. 40. What? Am I crazy? Have I gone crazy? I think I've gone crazy. All right. So FF should be all bits, right? Okay, this calculator's crazy. Oh, okay, here it is, all bits, right? So if I want just the high bit, then that's 128, which is 80. Okay, cool. I'm not crazy. All right. So glad I checked. So 80 is just the high bit. So if we take 80 and we shift it over by J, then that puts a 1 into whatever place that we want to look at for right now. So let's just AND that with 80 shifted over by J. And I apologize for the atrocious code. I know it's atrocious. It's just atrocious. Okay, so what we're going to do is we're going to make that makes, and we're going to run it, and then we're going to get a mess. Okay, look at that, mess. Okay, progress. We're getting a mess all over the screen. Okay, got to go now. It's getting late here. Have fun. Thank you, Era Otson Plots, and congratulations on your breakthrough ARM FreeBSD kernel while I was messing around with this terrible stuff. Looks like you're clicking randomly on our screen. No calculator. Yeah, the calculator didn't actually capture, so I apologize for that. I just did a quick Ubuntu calculator in programming mode. First try, Math Fisher. That's a great icon. I'm gonna give myself the dumpster fire for this code, by the way. So that CC65 is a compiler that compiles for Nintendo. Yep, CC65 actually does a whole bunch of 6502 machines. You can do Apple IIe, you can do Commodore 64. You just specify like what format you want. It's not a full C compiler, so like it's got a bunch of gotchas, and it doesn't do the optimizing the way like a modern GCC will. Like for example, you have to declare your variables first. You cannot inline them. So like if I tried to like pull something like modern, like say unsigned char down here, this would throw up. So can't do that. I'm sorry, Mustafa. I probably should have explained that a little earlier. I don't understand NES CC65. Yeah, this is it's a fun retro thing. Why did I choose CC65? It's one of the few C compilers available for the Nintendo, and I didn't want to write everything in assembly, although I feel like I'm going to be writing a lot more in assembly from this point on, because this routine is not going to go well. 715209, how are you doing? Good to see you. Been a little while. So I think, first try. Math is totally on here. Math Fisher, by the way, not my math. My math is not totally on. So we're going to unroll this later. We're just going to look at that. And I have a feeling that you know what I would like to see before we do that? I want to just off by 1 check myself here, because I'm not trusting any of my math today. Let's just VRAM put everything, and actually, you know, let's use J. And let's just take a quick look at that. And okay, so yeah, nice. Okay, junk all over the screen. Let's do this once, and then we're gonna break it. Break the loop right there. So okay, so it wrote out 0, 1, 2, 3, 4, 5, 6, 7. Cool. So that actually wrote out 8. One of the bits of fun you get with an NES is there's no, I mean, you can't printf debug. So you'd actually have to implement your printf routine if you wanted to do that. So I just wanted to check that we're actually running this loop the right number of times. We are. So this is going to range from 0 to 7, which is cool. And that means that let's get back to this little bit of bit math before we wrap up. I'm going to wrap up shortly. I'm good, and you? I'm having math issues today. 715. Just that kind of day for me. So, okay. And the way we're doing this is we're taking 80 and we're shifting it over by J. So on the 0, we're shifting it not at all. And on the 7th one, we're shifting it 7 spots, which is cool. And then we're ANDing that with the current entry. And if it's not equal to 0, so if we get anything, then we're putting the up arrow, which is VRAM put 2. Otherwise, we're printing out black. Now, let's figure out what went wrong there. So, that what? Oh, I did a break. I gotta get rid of that break. Okay, so we get rid of that break, make this thing, change screen, and we're getting this. So let's throw let's put a pill value in here. So I'm just going to edit the level data real quick, and let's do FF for the first entry. So this should be all up arrows, which it is, except there's 8 up arrows. Okay. So if I do 80, actually here, if we do 0F, then the first 4 should be black and the next 4 should be up arrows. And that's not what we're getting. Okay, so let's figure that out. So 0F, this is the right piece of memory, because this is level 1 bin. I is going to be 0. VRAM put happens. You know what? We're going to break after the first one. We're only going to process the first. Yeah. Okay. So there. So we're not clearing the screen anymore, but we are getting this. It thinks that it's all ones, and that's not right, because we can see here if we do just a 1. Okay, so I've got my AND logic is wrong. So 80 shifted over by J. And it not equal to 0. Put it. Huh. All right, I guess I should have unrolled it. Let's, you know, I don't want to debug that. Let's yeah, let's just brute force it. I don't want to figure that out. All right, so we're gonna go here because I got to run for dinner soon. And let's just manually do this. This is going to be ampersand 80 not equal to 0. Then here, this stuff looks all good. So let's just pull this back over. All right, so we run that, and okay, so the first one is set, but in my source, the first one is not set. Okay. So for some reason, this is not right. So when I and this thing, wow, that's crazy. All right, what am I getting wrong there? Did I not rebuild it? Is that? No, it rebuilt. Okay. That's nuts. So this thing, I0. Okay, we got our break. And it's clearly putting the 2 in there because we're seeing the up arrow. So it's hitting this branch. The only way it can hit this branch, this thing is not equal to 0. And when I AND it with 1, oh, 1 ANDed with 1 is equal to 0. Okay, so that should hit, but this should not hit. But that one hits too. Okay, so AND is not working. Man. Man, it's just gonna be one of those days, isn't it? Because 01 and 80. Am I crazy here? Like, is that OX80? I'm gonna look at that calculator again. All right, so if I specify 80, 1 0 0 0 0 0 0. Yeah, okay, it's what I think it is. 4 2 1. Visibly twitching, I am sure that I've got something wrong here. So that's, I mean, what I was thinking was you AND it with a single bit. So both bits have to be set, right? For it to hit. Otherwise it's equal to 0. If I mean, I'm ANDing this bit with, yeah, 80 is the right bit. I mean, it's the high bit. So I AND 0 1 with 80, and it should be 0. Let's just make sure I'm not crazy here. Yeah, it's 0. It definitely is 0, right? I mean, because you'd need, that should be the only one that hits. And I'm saying not equal to 0, but it is equal to 0. Versus like the case where it hits, you know, like for example, if this is FF, then that bit is set. So then you end up getting the value here. All right, you know what? I'll just test the value. Let's go the other way. So if this is 80, so if I get that bit back out, yeah, that's what doesn't make sense, right? Because the, is it not? No, I included it, so it can't, like, yeah, it's included right here. Is this the right file? That's crazy, because that shouldn't be the case. Level 1 bin H. Yeah, okay, this is definitely set to 0 1. Yeah, it should hit the else case. That's what I'm not understanding visibly twitching is that like it's not hitting the else case. It's hitting the main, it's hitting here, and it's putting VRAM put 2 is the up arrow. So we're seeing the up arrow on the output. So that means it's taking this branch, but that's not what we want. We want it to, like in this case, we want it to hit this branch, which should be a black square. Odd. There's something very simple here that I'm missing, and I'm not sure what it is. So let's, well, you know, like all debugging, let's just go piece by piece in this expression. So if we guarantee that this is 0, let's just take this entirely out of the loop. So this happens. Let's take the loop and get rid of it for the moment, except I've got another one here and I need to get rid of that. So we make this thing result of comparisons constant 44. Yeah, of course it's constant. I'm doing constants now. So this make run. I have a feeling that C is doing something that I'm not expecting here. So this is, yeah, it's set to 0, 1. So this thing and 80 is equal to 80, which it shouldn't be. So let's just really make it a constant. So this should hit, right? And that doesn't hit. Okay. So it seems to be exactly the opposite of what I think it is. So 80 and 80 is equal to 80 is false, so it's showing this. So not equal? What? This is totally, no, okay, so that works. Maybe it's a precedence thing. Oh man, that would be, I would hate myself. Oh, come on. And has lower precedence. Oh, come on. Oh, come on. It was the precedence. Oh, man. Oh. And here I was trying to use C to save myself time instead of writing this thing in assembly. And that, oh, man, I just paid for writing in C. The gods of the 6502 are angry at me, and they have smoten me. I will be smoted. That's not the past tense at all. I have been smoted. I'm sorry for your loss. Thank you, visibly twitching. I'm now visibly twitching. Okay, so Cam, it was all this time, it was the precedence of the bitwise and was lower than the precedence of the double equal sign Boolean comparison. So this was lower precedence. So it was actually comparing 80 to 80 instead of doing 80 and level and the actual level block to 80. Yeah, it's order of operations. Oh, man. Damn it. So we can change this to not equal to 0, and this should work now, which it does. So it hits the else case. And just to make sure that I didn't blow it up there, let's actually check it against what it says it is. This is why when debugging, you isolate things. And it shows up. Okay. All right. So I thought I was going crazy for a while. All right. Fine. Let's put this back where it belongs. Let's undo this disaster nonsense. All right. Let's go back to, you know what? I'll bet this wasn't really that wrong. Famous last words, right? So we're going to save this as the golden, it's right up there so I can look at it when this doesn't work. And we're going to take that. Now we're just going to do a byte of this, and then we're going to break. And what we're going to do is we're going to take that thing and we're going to remember to do the order of operations. So, and this is taking the high bit, shifting it over by J. So the first time that's 0, so you shift over by 0, which hopefully no ops. We don't have a compiler bug. We'll find that out momentarily. And if that's not equal 0, then put the up there. All right, so we try that, and yeah, okay, so it hits over here on the 8th bit, which is what we want with the number 1. So if we come back here and we put this back to its original value, which I think was 80, it's been so long, then this hits, which is in the right spot. And if we take the next bit, which would be 40, because we're working in hex, but actually then it does the next one. Okay, this looks like it's doing the right thing. Okay. So let's put this back to 80 and let's just run through the whole thing. So we come here and we don't break anymore. Okay, so we're going to do that. Oh my God. There we are. It's dinner time. You see that? That is what we did so many moons ago when we drew it in the pixel editor. And I said, I'll just be real quick. We'll just make sure that we can import that. Yeah, okay, real quick. Real quick, right. Yeah, not real quick at all. Okay, but we can see that we actually got that picture there. So we are totally back in the realm of sanity. Now, Bitboi has been added. He's standing on this. At this point, we should be able to update these maps relatively easy. Now, we also can check our bit alignment. Looks like we're spot on. These 3 dots that I put in the corner, 3 dots in the corner, 3 dots in the corner, 3 dots in the corner, and these 2 things, and they're all aligned. And we're seeing all of them as well. So we're getting all the way from the, I drew 4, if I recall. Yeah, there's 4 lines here, 4 lines here, and they're all matched up. And so all right, so we know how to import after a lot of pain. Okay. Back in the real of sanity is a bold statement. That's true. I should be, I'm at least as sane as I was an hour or so ago. Good lesson on operator precedence for me learning C, so I thank you, and the pain was worth it. I appreciate it. Thank you, Visibly Twitching. I do like that name. It's a great name. Okay, so now, because it should be fun, I'm going to take one crack at this before we close up stream, and we're just going to write in here something something great. So we're going to just write a where's my write tool? Okay, so let's do, because I feel like the theme here was, that's a terrible one, so I'm going to not do that. So I feel like the theme here was the ampersand. Let's get a better ampersand. The theme was the ampersand, so I feel like a nice big ampersand in the middle is the way we need to go with this. So let's save that and let's run through our pipeline real fast, which should basically just involve running this Python program. And if we do that, and oh, you know what? I totally didn't show you the cut. So I drew this ampersand here. So I'm sorry, that's my bad. So I drew a nice big ampersand in the middle of our map. All right, so we're gonna cut back to the other screen, and we're going to see what happens when we try to put the ampersand on, which is that we're going to make it, and we're gonna make run it. And we get absolutely nothing because I forgot to do the other thing, which is xxd of level 1 bin into level 1 bin, because it has to be a .h file. Then we're going to make it, and then we're going to run it, and then we're going to see absolutely nothing. And so I'm going to go insane. So that's nice. Why did you do that? What? No, that should work. Did I save it in the wrong thing again? All right, so let's just take a quick look at level 1 bin. And I don't see an ampersand there. I feel like that's not it. So let's just take a look at what we exported. So this, we were printing out all sorts of bytes. I'm going to take a quick look to make sure that that's saved. Which that, no, we're not. This we're not worried about. So we're going to come over here and look over here at level1.png. I'm just going to look. Yeah, it's not saved. Okay, that's nice because I saved it as a Pico file. That's great. That's very helpful as a Pico file. I'm going to do save as. You know what? I'm not going to do save as at all. I'm going to use the other thing. I'm going to do export because that's actually what we want. And we're going to call it level1 PNG. Are you sure you want to replace it? Yes, I do want to replace it. I really want to replace it. I want to replace it with this thing, and I want to do that thing, and I want to do this thing. And nothing happens. What? Okay, did I remember all the steps? Okay, so I didn't run my other thing. That's why. Okay, so you need to, so after we export the PNG, and I'm going to double check that I exported it this time. Yeah, okay, I did. Good. Then we need to run the Python tool to build the binary, and then we need to do xxd to turn the binary into level1 bin.h. Okay, I see some more stuff this time, and now we can make this thing, and we can make run it. Et voila, there you go. The theme is remember your ampersand, order of operations, precedence. That's it right there. Guy going insane. Thank you for clipping that, Cam. I appreciate it. And there we go. All right. Thank you. Chat, thank you for bearing with. That was a little bit more painful than I expected. Test pass. That's a fantastic. I like that one. Coding GTP. I don't know who coding. I gotta see that, dude. That's some good emotes there. This would have been an apt end if there wasn't some difficulty generating the level. Yeah, I need to clip the first part, but I didn't. That's all right. Okay, well, anyway, I want to thank all of you for hanging out today. So we got our level editor. Our level editor is now basically being able to write out pixels. So for those of you interested, we're negotiating times right now, sort of like afternoon, sort of like we talked about before. Come join us on the Discord if you're a Discord sort of person. And I'm going to be doing 3 days a week, and I'm going to commit on the slots, but I'm not necessarily going to commit on what the topic is. That'll probably float a little bit. But I could be a little bit more regular about when that happens. And I have a beautiful NES up arrow version of my map. We could actually turn this into any tile we want at this point, which is really nice. Yeah, so I'm gonna finish up this NES coding. Next couple streams, I want to finish this up and get it over to Trevor. So for those of you who don't know, Trevor streams video game music. He plays piano on Twitch, and he's really good. So. Totally alpha unstable. Absolutely, Cam. That is a apt description. Yeah, the ampersand. There's a nice big ampersand for you just to know the pain. Okay, so anyway, I will see you. The next stream is going to be on Tuesday with Jesse. If Jesse's not available, I will be streaming anyway. So hopefully Jessie is available. She usually is. And anyway, have a fun rest of your weekend, and I will see you all later. So take care. Program safely with order of operations.